Good morning, good afternoon, good evening, wherever you may be watching this from. This is Cornelius Lubin with another video, and in this video we are continuing and we are still looking at the calculus 2, which is applications of differentiation. And now we are looking at the subtopic, which is tangents and normals, example 2. We are starting with question A, which reads: find the x-coordinate of the point on the curve y is equal to 2x cubed plus x squared minus 2x plus 1, where the curve is parallel to the line y is equal to 2x. So already in that statement there is a lot of valuable information. We have been told it is parallel to the line y is equal to 2x. It means that the gradient of this line, because of the word parallel, is the same as the gradient of the curve. It is the same as the gradient of the curve at that point. So it's the same as the gradient of the curve at that point. So there's a particular point on the curve which will give us a gradient that is equal to the gradient of the line y is equal to 2x. So we have the line y is equal to 2x. What is the gradient for this line? So the gradient, what we do is we get the number just before x, alright, or the number in front of x. This number right here, and in this case the number is 2, so gradient is equal to 2. And then we write our equation: y is equal to 2x cubed, okay, plus x squared minus 2x plus 1. Then we find our derivative: dy dx is equal to 6x squared plus 2x minus 2. After doing this, what we have found is called our gradient function. Dy dx is called the gradient function, okay? And then they are saying that, and then we have said, okay, in the question, they have told us that the gradient is equal to 2. So it's simply meaning that 6x squared plus 2x minus 2 is equal to 2. Simply means dy dx is equal to 2. What you found for your dy dx should equal 2. And then now you solve the new quadratic equation that is formed. It's going to become 6x squared plus 2x minus 2 is equal to 0. And then 6x squared plus 2x minus 4 is equal to 0. Then to continue, you are going to clean up like that. You solve the quadratic, which is 6x squared plus 2x minus 4 is equal to 0. We divide throughout by 2. 2 can go into itself 1, into 6 it's a 3. 2 can go into itself 1, into 2 it's a 1. 2 can go into itself 1, into 4 it's a 2. So 3x squared plus x, okay, minus 2 is equal to 0. Then we're going to solve that quadratic equation using factorization. The product here is negative 6. The sum is a positive 1. Which two numbers when you multiply give you a negative 6? When you add, they give you a positive 1. Okay, think of factors. Think of factors that can go into into negative 6. So it means also think of the negative numbers. Which means in your head, think about integers. Alright, and the two numbers are positive 3 and negative 2. When you multiply them, they'll give you negative 6. When you add them, they will give you a positive 1. So this is going to be 3x squared plus 3x minus x minus 2 is equal to, sorry, not like this, minus 2x minus 2, okay, is equal to 0. And then we clean up down there. After we form something like this, we factorize by grouping. It's going to become 3x multiplied by x plus 1. Factor out negative 2. It's going to become x plus 1 is equal to 0. So x plus 1 multiplied by 3x minus 2 is equal to 0. X plus 1 is equal to 0, or 3x minus 2 is equal to 0. It simply means we are going to say 3x is equal to 2. We divide by 3, we divide by 3. 3 can go into itself 1, into itself 1. So it means x is equal to negative 1, or x is equal to a 2 over 3. So the x coordinate of the point on the curve. They said x coordinate, not x coordinates, right? Of the points. But we have found 2x coordinates. It is okay. It is either at the point where x is equal to -1 or the point where x is equal to 2/3. If we substitute this into our dy dx, we are going to have dy dx is equal to 2, which is the gradient right here for the line y is equal to 2x. So we can clean up like that. We go to question B, okay, which reads, is any part of the curve parallel to the line y is equal to 3x plus 1. So we have the line y is equal to y plus 3x is equal to 1. So you write it in the slope intercept form or the gradient intercept form. Y is equal to -3x plus 1. Then after writing it in the gradient intercept form, you can see that the number in front of x is a -3. So that -3 is actually your gradient, okay? M is equal to -3. The question reads, is any part of the curve parallel to this line? So the only thing that we need to consider is the gradient. Is this gradient going to give us, okay? Is it going to give us an answer if we solve? If we solve and then we get an answer, it means it is parallel to this curve. I hope that makes sense. So we have y is equal to 2x cubed, like that, plus x squared minus 2x plus 1, okay? And then we are going to find the derivative, the dy dx. If you remember from the previous answering, it was 6x squared plus 2x minus 2. And then we are going to say 6x squared plus 2x minus 2, okay, is equal to a -3. That's what it means. You just say dy dx is now equal to -3. What you have found for your dy dx is equal to a -3. Then you group like them together, it's going to become 6x squared plus 2x minus 2, okay? Then it's going to be plus 3 is equal to 0. To continue, we are going to clean up. This is going to become 6x squared, okay, plus 2x, like that, then plus 1 is equal to 0. This is the new quadratic equation we have formed. So the product is a +6, and then the sum is a +2. If you think of it, actually, this equation has no real solutions. How I can prove it is the discriminant is going to give us a negative answer. The discriminant is a part that is under the square root. What do I mean? Let's solve this using the quadratic formula. X is equal to -b plus or minus square root of what? B squared minus 4ac divided by 2a. It's going to be -2 plus or minus square root of b, which is -2. Square root of b, which is +2 squared minus 4 multiplied by a, which is a 6. C, which is a +1, you divide by 2 times +6. It's going to become -2 plus or minus the square root of what? This is 4 minus 6 times 4 is going to give you a 24. You divide by a +12. And then we can clean up. It's going to become x is equal to a -2 plus or minus the square root of a -20 divided by a +12. So, as you can see, the square root of a negative number, right there, square root of -20. In addition to mathematics, this is not at our level, okay? It's going to give imaginary roots. So, because it's not giving us real solutions, if it was a positive number, I would have found the solution. Now, if it's a negative number in the square root, no real roots, how do you conclude? Therefore, the line y plus 3x is equal to 1 is not parallel to the curve because it has no real roots. So actually, when you find a negative number in the square root, just know that it will never be parallel. Actually, this curve, it will never be parallel to that. This line will never be parallel to that curve. So, because of a negative in the square root, it will give us no real roots. Okay, this marks the end of this video. Thank you so much for watching. This has been Cornelius to be in another video, and bye-bye.